Ladies and gentlemen, welcome to another epic afternoon. Welcome to very exciting 2 hours of your life. On Monday, November 23rd, our epic meeting is on 3D sensing. We are living through the second photonics revolution. That means components, pixels, and micro-optics are already in our pockets. Face ID has 1 in a million chance of being fooled, which explains why it's being accepted as a replacement for passwords and even physical keys. Face ID works by projecting 30,000 dots on your face. But our smartphone cameras can also measure mood, detecting if we are happy, sad, overtired, or even sick. This new boom in 3D sensing is going to revolutionize the way engineers build the world. We can measure the volume of everything in front of us and estimate their composition, hence knowing its weight. Also, motion and environment capture are key to augmented reality games. 3D sensing can fix the €1 trillion problem for online retailers. Up to 40% of clothes get returned when they do not fit. 3D sensing is also impacting the world of e-mobility. It's increasing the safety level in advanced driving assistance systems and even enabling the self-driving cars around the corner. And in manufacturing lines, high-speed 3D inspection is now commonplace. But there's still a lot to do. Current technologies in autonomous driving still have difficulties coping with bright sunlight and long-range measurements. We need better solutions to measure large objects at a distance like trucks or wind turbines. So with the focus on the near future, join us for our meeting on Monday, November 23rd. Our target list includes consumer electronics giants like Broadcom, leading camera manufacturers like Jabil Optics, promising future gazelles like PROPHESEE, defense-related companies like BAE Systems, as well as automotive tier 1s such as Ibeo. And to close the gap, key photonic companies like Viavi, Excelitas or AMS, and semiconductor giants, including ST Microelectronics. To participate, remember to sign up for the Zoom room or follow your YouTube 3D sensors starting precisely at 3 p.m.
Jose, wow, you look like you need another espresso.
I definitely don't need another espresso. I drank 10 today. I think I'm full of energies myself. Thank you very much, all of you, for talking about 3D sensing. This is the 53rd of the Epic Online Technology meetings. We keep having a lot of success with the concept, but it wouldn't be possible without 633 companies supporting us. So to each and one of these 633 companies, thank you from the bottom of our heart. Christmas is coming soon, and with this, the end of Q4 2020. We still have 5 meetings after this one. Keep an eye on the meeting on the 7th of December, robotics, industrial LIDAR, and factory automation, because it's shaping up to be excellent. Keep an eye on that, and if you are available for 2 hours your time on the 7th of December, Monday, do not miss it. It's going to be epic. I would like to say thank you also on behalf of a fantastic team. You all know them. They are rock stars on their field, organize events, provide network, provide investment, have the biggest website on jobs for photonics industry, jobsinphotonics.com, and we keep providing you with market reports. All of you who are members of Epic know this very well. We love that we can give you market reports that we get commercially from market analysts and we give for you for free because you support us being member of this fantastic association. Today's 3D sensing. We have a long list of sponsors. Thank you for there, and I say AEMtec. AEMtec is the company in Epic who provides back-end solution for the packaging of optical sensors and integrated photonics, as well as microelectronics. Advanced coatings. If you're looking for black coating, don't look any further. These guys have make the perfect coating for full absorption. Imasenic, on the way from beautiful Barcelona. You're looking for custom CMOS image sensors to make innovative products. They achieve high resolution, cost-effective, and first-and-right designs for 3D sensing. We go to NIL Technology, all the way from Denmark. If you are looking for a provider of molds and high-end micro-optic solutions, all the way to multi multi-level optics, high-end micro-optics, which is the revolution of Europe. High-end micro-optics is the technology of NIL Technology. DELO industrial adhesives. If you're looking for the right provider of polymer to do the perfect optical adhesive of different optics, go to DELO. They provide the best adhesives in this industry. Optic balsers. Optic balsers make coatings for the best filters and thin film solutions on the 3D sensing industry. They work in automotive, mobile devices, and industrial applications. And you go to also equipment suppliers for micro-optics and electronics manufacturing, EVG, all the way from Austria, Florian and Ning. EVG provides the machines for the manufacturing of micro-optics, optics, and semiconductor products. And Excelitas, I couldn't finish with a better company. Excelitas is the company that provides almost every photonic component, but if you're looking for the best detectors that CMOS industry needs, the best detectors that 3D sensing needs, you go to Excelitas and you get them. And I almost had no notes to deliver all that. I go now back to Sana, who's going to tell us what's in the menu today.
Thank you so much, Jose. Thank you for this fantastic introduction. Today we have amazing speakers from some key players in this field, but let's see the whole supply chain that we will be presenting today. We covered everything basically related to 3D sensing, from semiconductors, CMOS, to integrator, system integrator, vision and camera providers, and we have people doing packaging and assembly, to the software, to the material, the coating, the metrology and testing, and of course a giant in semiconductors, like you just named it early, optics and micro-optics that are getting a lot of interest in this field. And of course, if there is something missing, then we have here the R&D research centers to provide it. But most importantly, we have the end users from automotive, Earth observation, from Huawei, consumer electronics, and from Intel. I'm very happy to start this meeting today. Let's start.
If there is something missing, we also had Dr. Sana Pico with us, that he's doing a spectacular job on bringing the entire supply chain of 3D sensing together. This took a lot of work, so congratulations on a fantastic job today.
Thank you.
This slide represents only the companies who registered for this meeting. If you are missing your logo at this slide, that doesn't mean that Epic forgets about you. Epic will never forget about any of the members. This slide only represents the participant list today, a graphical representation of the participant list. I say this because we still get emails saying, you forgot my company. We never forgot any. And I also would like to say hello to people who also don't forget, the people who are following this meeting in YouTube. If you are following the meeting in YouTube, hello YouTubers on the world, all you have to do if you want to get in touch with any of the participants is to send me an email, jose.pozo@epic-asot.com, and I will be more than happy to make that introduction. And with this, now I relax a little bit because I have something very cool to say. Nobody can make anything alone anymore in this industry. So Epic is partnering with EMVA, the European Machine Vision Association. The reason for that is we want to keep giving value to our members, the same one as MVA. And we had the same target, to bring the end users, especially in the process monitoring, robotic, and high-end manufacturing industry, to tell the Epic members and the EMVA members what they need. EMVA has been extremely active on driving standards and driving new ways of doing, including hyperspectral imaging in different process monitoring sectors. We do have overlap, but now we also have a friendship. I would say a brotherhood or sisterhood. Thank you very much, EMVA, for helping us. We are going to do the same thing to you. I know Thomas from EMVA is in the room. So Thomas, hello, good afternoon.
Hello, good afternoon, Jose. Good afternoon, everybody. Thank you very much.
So what are we going to do together?
Excuse me?
What are we going to do together?
I don't know yet, but I'm sure we will find some ideas, basically promoting interesting topics, interesting technologies and innovations in our both communities. I think that is the very first step we want to do in the next weeks and months. You are doing already a perfect job here, so what can I add? You basically already said everything. Thanks.
Thank you very much, Thomas. Thank you, EMVA. Remember, this meeting is about doing business, If you came here to look for suppliers or customers, you're at the right place. After the meeting, when the meeting is finished exactly at 5 o'clock, you can stay in the room and we will arrange one-on-one private meetings so you can finalized, you can put the cherry on the top of the cake that we are going to bake for the next 2 hours. Let's start baking, Sana. Are you ready? I think I'm ready. Why don't we go to our first speaker today? And we start with a giant in this industry. They cast a big shadow. They make fantastic processors. They make fantastic optoelectronics. They make fantastic pixels. Broadcom, Martin Weigert, Vice President and General Manager on the Industrial Fiber Optics at Broadcom. Thank you very much for being with us. Let's get the ball rolling. The floor and the attention of everyone goes to the giant Broadcom.
Hello, everybody. Thanks for inviting me. My name is Martin Weigert. I'm located in Germany, working for Broadcom, running a business unit there. And today I'm going to talk about silicon detectors configuration for optimizing LIDAR systems. So we're focusing on LIDAR automotive, and on that side, on the receiver side. So hopefully that works now. All right, here we go. So basically in a LIDAR system, you usually have an emitting side like a VCSEL or DFB or edge emitters. And latest technologies are arrays where you don't need moving parts. You can make a beam and a beam steering. And ideally, that's on 905 nanometers. Then you can silicon as a detector. And what we do is we integrate silicon photomultipliers or APDs in CMOS. So we have an APD array integrated in a CMOS process. And then we can align the transmitter with the receiver side. And that gives you a huge advantage in terms of signal noise ratio. So it is a synchronization of emitter and detectors. And how it works will be shown on the next slide. So we have an array, a lot of integrated APDs, and then you can switch it through. One line is on, and all the other APDs are off. And basically, the parts which are off do not contribute to any noise. So we can switch the APDs how the system manufacturer likes it. And then you get much less noise from the TIAs. And you can also do a combination or a multiplexing of these detectors. So that's pretty unique in the market for now. How it works, so we have a kind of ASIC, which only needs a 5-volt external supply. We have internal voltage regulators, step-up converters. So we generate the high voltage in the chip. We measure temperature to adjust the APD behavior. And then we can do pixel matrices up to 96 to 125 as an example. We come up with the line buffer, so integrated TIA. So it's all in one chip. So the detector is basically an array of highly sensitive APDs, which can be switched up and down if you like. The other technology we have in place are silicon photomultipliers optimized for near infrared. There's one product which we launch now early next year for 1 by 1 millimeter. And that's a silicon photomultiplier with a PDE of 18%, which is pretty good in the market. In 905 nanometer, we have a wide dynamic range, very fast cell recharge time of less than 10 nanoseconds, low bias, and its operating temperatures for automotive is minus 40 to 85 degrees. And here we go. You can also do arrays with that technology. So for example, a 1 by 12 array, same PDE. Samples are targeted for next half of next year. And that's also for automotive with the ACQ 102 regulations, a compact package. And that's an ideal detector for LIDAR. And comparing to some competitors in the market, we're pretty good in terms of the PDE. What you see here, we know one has 7, the other 5.6. We're coming up with 18. We're pretty confident that we can even increase this number, and recharge time is pretty low. So basic messages. If you want to do LIDAR, you need a very good performance. You need low cost, and with silicon, we can do low cost. There is no need for a high expensive product, and performance is there. And I think it's good enough for a long range LIDAR for 250 meters frontline LIDAR in the car. All right, that's it.
Thank you very much for this very nice talk. And you know how it goes with EPIC meetings. That is what we call the EPIC question. You tell us what you know how to do, and what you do, what we can do to the others. And we want to know what can the others do for you. What kind of collaborations are you open for? Or what is it that you're looking for in this room?
All right, so we are focusing on the detector only, and we're very open for LiDAR manufacturers to support them with a so-called ASIC detector, so they can choose the number of rows and lines and the specifications. So we are very open to customers for doing customized ASICs for LiDAR, either with integrated APD and CMOS or with the silicon photomultipliers.
All right. You escaped my question a little bit.
Yeah, sorry.
We want to know what can the others do for you, or what is it that you're looking for in this market?
Yeah, so collaborations for companies doing the transmitter side, and collaborations companies doing the whole LiDAR system. The whole
LiDAR system. All right. Let me see first if we have a question in the room. As we are about 82 people in the Zoom room now, I would like to kindly ask you to just unmute and ask your question.
I would have a question. Simon from Jabil.
Hi, Simon.
An interesting talk. Thank you very much for that. You addressed that you are looking into, let's say, enabling lower cost LiDAR. Can you compare your solution in terms of cost to existing ones?
Yeah, so you can always compare it to 3.5, like 15 nanometer. The system cost will be definitely higher. You have expensive lasers. You need 3.5 devices on the receiver side. We are using a relatively cheap silicon. On 8-inch, we can scale it up to 12-inch. So on the detector side with silicon, it will be cheaper than a 3.5 solution. If you ask me, what's the difference on discrete APDs? There is a technology difference. So we have an array. We can package an array and then integrate the whole electronics into the APDs, which makes it cheaper than a discrete solution. On the silicon photomultiplier side, it's really about the performance.
All right, thank you.
You're welcome.
Thank you so much, Simone, and thank you. Let me see if there is another question in the room. Please yeah.
I would have another question. Hi, yeah, thanks a lot. Hanno Holzhüter here from IBO. I have a question regarding your ZIPIMs. You showed an array of 1 by 12. For us, it's always important to have 2D arrays because we, as you said, we want to scan solid states. We don't want to have any moving parts. What is your roadmap regarding ZIPIMs in a 2D array? Do you have any plans? Maybe
yeah, we can do that. No problem. We can do 1 by 16 if you like, or other form factors. That's why I said it's an ASIC, right?
Yeah. What about? I mean, going up from, I don't know, for 80 by 100 or so. Is that in a real 2D array?
Okay. If you're talking more than 2 rows, it's a little bit more complicated, and I probably need to talk in more details. Most likely offline with my technical colleagues.
Okay. Thanks.
You're welcome.
Yeah, this is the main goal of these meetings, to push forward these kind of challenges. And if there is no more question in the room, I would like to.
I have a question. Yes. So it is clear for me that Broadcom came here with a fantastic detector, and I think there is an obvious partnership. Farzad is here from Sun Microsystems, right, Farzad? Farzad from Sun Microsystems, 3, 2, 1.
Yes.
Yes, he is here with us.
You hear me?
And I know very well your technology. You are really quite an expert on the assembly of detectors for many different 3D sensing applications with other components. Well, tell us what Sun Microsystems do, and then we can see that there is obvious room for cooperation with Broadcom.
Okay, we provide solutions for 3D sensors and LiDAR challenges. This is ASIC and co-packaging. And one part is indeed also the receive channel. That's why I actually wanted to ask also Martin Weigert if their solutions can be changed or can be customized if some customers want something specific. And we provide actually the ASIC integration or also mini ASIC or MPW services with some partners also in EU projects. This in one part. And what else that we also provide is for FMCW LiDAR, there is a big challenge regarding the linearity of the laser wavelengths or laser frequency, and we provide electronics on ASIC to minimize this nonlinearity. And back to my question, do you provide also custom solutions if something totally different than what you have is desired?
Yeah, for sure. On the receiver side, we are very open to that.
Okay.
I'm also interested in all kind of advanced or automotive suitable packages for these arrays. It's not so easy to make large detector chips and then get the right package for it.
Exactly. This is one big topic as well. That's we have some partners, packaging companies that we work with them very closely, and there are some solutions. Also, not only in the receive part, more critical is it on the transmit part. When you need to make very short laser pulses and very high power, then co-packaging is here very, very important. And with smallest parasitics, you mess up everything. So it is also, in that case,
yeah. So what you're showing on your slide is basically a APD array, right? And then discrete electronics, and that's different ICs co-packaged.
This can be discrete, but also desirably it can be also an ASIC. This is what we provide solutions and know-how to this.
Right, because in our case we do all together in one chip.
Okay.
On the transmitter side, we're not active at the moment.
Okay. Okay. You do it in Germany or in California?
In Germany.
In Germany. Oh yeah. Okay. That sounds good. I know many customers, they are interested in this type of
Thank you so much, Martin.
Like
thank
to
you
contact you later to get more in touch. Yes.
Sure.
Thank you.
Thanks, everybody.
Great. We have our first room for after this meeting. Elena, just write a message to Elena. She will put you together later for a one-to-one meeting. And please allow me to welcome Bruno, our friend from AMS. We're looking forward to hear your talk today, Bruno. Please unmute.
Hi, everyone. So
Hi.
Let me share my screen.
Thank you so much. Here you go.
Okay. I quickly want to talk about what AMS is doing specifically in the industrial sector, where we are trying to create an ecosystem around our 3D components. I will quickly talk about our offering and then change about what we are looking in for partnerships. Just very quickly, AMS is a company around 9,000 employees with a little bit more than $2 billion US dollar revenue, with a good path of growth above the sector in the last years. It's focusing mainly in consumer market, but as well growing up in automotive, industrial, and medical applications. And specifically for 3D sensing, what we are offering are key components
I think we may be experiencing some delay, which is, this is the punishing for doing live. No, we risk-take. Bruno, are you back with us?
Yes.
Yes, we lost you for a couple of seconds, but we are still in slide 3, so the floor is yours.
Okay, sorry. I was saying that we are offering key components for 3D solutions. We are having our flat and dot projector based on our pixel technology, both offering integrated eye safety solutions to monitor the eye safety of the device. In case of the flat illuminator, we have best-in-class uniformity with multiple field of illuminations from very wide ones to very narrow with high optical signal density. And in both cases, we are using our in-house pixel technology that is high efficient. For the dot projectors, we are offering distinctive patterns with high contrasts. We are having specific IP solutions for dot projections that they are focus free. That means that you get the same resolution in the dot at all distance. And finally, we are having as well our image sensors that they are offering high quantum efficiency at near infrared wavelengths, and they are based in our proprietary global shutter technology for voltage. All these components, they can be integrated in 3D solutions. The dominant ones in the market are the stereo vision, structured light, and time of flight, where you need to have a projector sensor, and you need to have as well image sensors. And then for some markets, we have created our own reference designs that they can be used as evaluation as well to be integrated by our customers and partners. We are having like active vision system for mobile, for example, for face unlock, our Ceres platform. Then we are having like a structured light system for e-lock and e-payment, our Athena platform. As well, we are having a more generalistic 3D camera systems, a Hermes, where you can develop your own algorithms by using a USB connection to your PC. But this is what we are offering on our side. But then what we realize or know is like in the industrial market specifically, and in all the markets, but the industrial market is even more, industrial consumer market is even more important. Is like in order to tackle the opportunities on the market, you need to have a strong partnership and strong partners, and then you need to grow an ecosystem around your products, and this is what we are trying to grow. Here you can see some, like an example. We are providing our components to our partners in the software like Unity and Qualcomm, and as well manufacturing and system integration like Jabil, that are helping us to reach and provide the solutions to our customers to customize and tackle the problems that our customers are having. And then we are supporting them with our know-how and our components to help them to tackle their customers. And at the same time, we are as well partnering with our distributors to give the best customer support to our customer directly. And here is a small example of a constellation necessary to actually tackle these specific problems that you are finding in a market like industrial. What we can offer, or we offer to our partners, we can offer our 3D sensing components, right? Our illuminators, our image sensors. Then for some specific applications, we have reference design that can be used as a base, a starting point to customize for customers by our 3D system integrators and manufacturing partners like Jabil. And then on top in software side, then we are having our software solutions, especially for depth computation and face authentication, for example, where we can often licensing as well as starting point for a customization of the algorithms for the specific needs of the market. And then answering the epic question, right? What we are looking for is partners, right? We want to grow our ecosystem. We want to open our ecosystem, and we are looking for partners that actually want to use our components. They want to come into our ecosystem and then grow and tackle together the problems that the customers they are having on this area. That's all. Thank you very much.
Thank you very much, Bruno, for this. This is fantastic. You know why? Because for me, AMS is the company who has made the revolution of micro-optics in Europe. When you did the acquisition last year, everybody was talking about that, and you started getting the ball rolling. Micro-optics is big in Europe because we managed to reach the consumer market, and that was possible thanks to the branding, the positioning, the effort, and the hard work of companies like AMS. So congratulations on that, and the whole ecosystem. The 631 companies are here to offer you some help. You answered the epic question quite well already. So I'm going to try to find potential partnerships. If you left the meeting with one company that could help you, what could be the profile of that company? What is the biggest, if you can answer this, the biggest headache that could be solved today with this fantastic community?
As I said, mainly what we are looking is for partners that can help us to tackle specific problems for the market. Industrial is a fragmented market. Each customer has some problems, and then what we are offering are components that they can tackle a lot of systems and a lot of problems, but what we are looking for partners that they actually can take these components and actually customize the final solution system for the customers to solve the actual issue that the customers are facing. This is what we are looking.
You ask and I serve. I'm going to go to the Netherlands. And in the Netherlands, I have a lot of friends, not only because I live there, because it's by far the most active integrated photonics community in the world, the one that's assembled here in the Netherlands. I'm going to go to a company called Fix. Maybe you never heard of them, but you will, because we have an OSAT in Europe for the integration of optoelectronics. Jeroen Douws, they are looking for partners. What could you do with them?
Yeah, we're here to help. So if you need partners to do packaging and customization and also like thermal household and RF connection, I think we would be a partner to go to.
Jeroen, in the assembly of optoelectronics that is done today at Fix as a service to companies, one of the biggest application fields is becoming integrated solutions for LIDAR. When it comes to LIDAR, could you share with us when you are doing the assembly of different components, could be the first two challenges, maybe the light source, the detectors, the assembly, the temperature, what could the suppliers and the integrators here need to be worried about?
I think in the laser, we are doing quite some integrations of different laser schemes, either with very high power, narrow line widths, so thermal stability and packaging for the environment, especially for automotive, that it withstands the lifetime of like 10 years in a rather harsh environment, while on the other side, optimizing as well for cost. That's, I think, one of the biggest challenges that we're trying to tackle. So not everything needs to be hermetically packaged, but like on the other side, you need to figure out to what level is it required. Can we work out with like getters inside the package and make semi-hermetic packages that are good enough for such market application?
As I said before, Jeroen, you are one of the success stories of this industry. Having an OSAT in Europe doing the assembly of optoelectronics is huge. So congratulations on setting on this important milestone for the supply chain. Are there any questions or room for cooperation with Austria MicroSystems, with AMS? I think we had the hand from Serge from Astrum LT. Yes? I believe you made a sign. Yes, do you have a question or room for cooperation?
Hi, hello.
Hi, Sergey.
Yes, I am actually have been in contact with AMS and was impressed by the technology. We have had several high power VCSELs through their partner distributor, and I have no question at the moment. So yeah,
the cooperation is there. If you're looking for high power solutions, especially on the VCSEL side, Astrum LT is a key company in the ecosystem. Bruno, one more thing. When it comes to reaching the automotive industry for different applications, it is very important to be automotively qualified. I know AMS has invested and AMS is there, but what is the challenge for your suppliers? Are they automatically automotive qualified that they work with you, or is there a checklist that you need to do to validate your suppliers?
No, definitely you need to validate your suppliers. We have been qualifying our production site for automotive devices that we are doing, for example, VCSEL production and some packaging illuminator that we are doing. And our suppliers, we have OSAT supply chain, mainly not in Europe. And then our partners have been, they pursued the automotive qualification of the lines, for example, that is necessary to be completely compliant.
This is very important because I said before, we are living now this revolution of micro-optics in Europe. I want to set up a strong supply chain, and having AMS doing the validation of these suppliers is a very, very important role. Bruno, thank you very much for a great presentation. We're going to continue, but getting back to you in a bit. We continue and we go to the capital of optics in Jena. I'm going to say the capital of optics in the world. We go to Jabil Optics in Jena, and we want to hear from them what 631 members can do to make Jabil even better. The floor and the attention of everyone goes to Jabil Optics.
Thank you, Jose. Very interesting meeting so far already. I'm pleased to talk a little bit about system design and our optics expertise in 3D sensing. Can you see the slides? Very good. So 3D sensing, how we understand it, is a small form factor, world-looking, face-looking 3D sensing modules, for instance. What is required, key components that go into such solutions. This is not exhaustive, but it's mostly cameras, stereo cameras in the NIR range. It's RGB cameras. It's dot light projection modules, and not to forget electronics and precision mechanics. So when we look at these kind of modules, we are not looking at each a single component, but we look at the overall system. So we need to bring in a few more capabilities, especially for volume applications. If you talk about the camera technology, it's usually optical design, wide field of view, high resolution, small and not even small, but smallest form factor, which is required to fit into even smaller workspaces for these assemblies. High resolution up to 20 megapixel, even higher sometimes, enabling 4K video. Image quality, of course, is always key to the applications. Another very important point is active alignment. I know we have a few active alignment companies also on the call today, so I'm looking forward to their comments. So camera, laser, projection assembly, high throughput. So this is a high number of volumes, units per hours, multi-head optional alignment capabilities in the system. And of course, dispensing, curing, and a lot more on the active alignment side, which we have capabilities in-house. On the dot projector module, we can do also the system design on that assembly, considering flat dot, depth, or 3D. So there are various considerations to be taken. Edge emitting lasers versus VCSEL. There's a separate talk that I made a few weeks or months ago. We can also deep dive here. Of course, advanced optical design is required, especially for the DOE side, which we can do. Dot quality is decisive, and also miniaturization to really make these things small. Since we don't have a lot of time, I'm going to skip through the electronics precision mechanics part. Bottom message here is we all have these capabilities in-house also for tooling, etc., to really ensure a very speedy process in that sense. If you look at the active alignment portion, here's just a rough overview starting from the left, where you need to have a active alignment regarding focus and pointing for the NIR and the RGB camera. Those need to be aligned towards each other regarding pointing and baseline. On the right-hand side, you have kind of a line projector module that then needs to be aligned to the NIR cameras to end up with a module like this. This is a little aged. Systems today look a lot smaller, but I can't show all of this here. If you have specific questions regarding active alignment, please feel free to contact either myself or our company that is included in the Jabil environment, a company called Casales. And also Bernd is on the call today and on this meeting to answer questions regarding active alignment. Some applications that have been solved, Face ID, gesture recognition. I think most of people know what is available. What we at Jabil have already solved is illumination for driver monitoring cameras, light sources for 360-degree time-of-flight cameras. It's a little small in here, but there's another meeting coming up at EPIC on robotics and industrial LIDAR, and I'm going to be participating here to talk especially about this module on the right-hand side here. Flood illumination for 3D sensing and a lot more, and you see also here a LIDAR system that is really rolling up the market at the moment. Very important news, Jose, please allow me to mention that. Jabil is known for high volume at the moment, and we were forced to turn down sometimes lower volume businesses. But we respond to this need that we opened a creation center here in Jena, in Germany, where we offer design prototyping, sample builds up to C-sample or design verification, and even low volume manufacturing. And that's important for customers that do not immediately jump to really high volumes. We can mature this business here out of a facility within Jabil, and then enable the high volume business. This is something we are currently looking at with a partner, and there's a news coming out of a really intense cooperation going to start with AMS. that's just been signed to really cooperate on that level to mature these kind of businesses. Final words about Jabil. Jabil is around about 240,000 employees, having manufacturing sites all over the world, serving like 400 of the most well-known brands in mobility, automotive, and healthcare businesses. And we closed the last financial year at $27.3 billion in sales. Thank you.
Thank you so much, Simon, for this excellent news, mostly, and for all these advantages. And you know the epic question, right? We heard your first part, what you can do for the others, and you are expecting me to ask, what can the others do for you?
Yes, I would like to start with what the others can do for us. If you think about how to engage with Jabil, think about the overall system. Don't focus only on your component. Your component needs to fit into a higher integrated system, and where does it benefit? How does it integrate? If now, for our case, we have to assemble these kind of systems, how does it suit in there, and what is let's say the price and cost contribution, and what we can do for them. This is basically the one of the last slides I showed. We are not only known for the high volumes, we can also look into lower volume quantities now, which is, I think, a huge benefit for all the customers and all the people participating in these events.
Thank you very much. Let me see if there is a question in the room first. And I think we have a first question from René from NIL Technology. René, you can take the word.
Yeah, not so much a question, but you basically you challenged where you could be helped in the system integration. And I actually have one slide that I would like to share and talk a bit through that, because I think I have a whole 3-minute slot here to talk a bit more about this. So essentially at NIL, and I'd like to zoom in to Simone, what you presented, and in part also Bruno. You know, if you look at these modules, they're basically scattered with all sorts of optical modules in there. There's cameras, there's dot illuminators, there's structured light, there's time of flight, flood illuminators. And essentially at NIL, we are an optics company, and we divide our technology into 3 categories. One being the diffractive optical elements, something on the future displays, which is primarily for us augmented reality, but less relevant for this 3D sensing session. And the last one is the meta optics, which I would say is probably the forefront in technology when it comes to the optics side of things. But if we go to that first category, and that goes a little bit to the sort of Swiss cheese with all the holes and all the modules in those systems. Essentially at NIL, we have developed a way on how we can make the dot projectors, the pattern generators, but also the diffusers as well as the collimators into one technology platform. And that one technology platform is the diffractive technology. That's all, you know, what we do in-house. We do the manufacturing, we do the design, all that beautiful stuff. And essentially what we then created is that we have created one optical platform from which we can generate different optical functions. So the need to have micro lens arrays for diffusers and DOEs for structured light and refractives for collimators and cameras is all being merged into one platform of technology. And if you look at number C, that goes then more to the camera side of things, where we are pioneering and having first prototypes and results out of the manufacturing of our meta lens services, which basically is a replacement for traditional refractive lenses. And they are essentially optical nanostructures, which have a similar functionality. And then we can significantly reduce the thickness and the complexity and the amount of elements you need on the camera side. And we make those with, well, the typical applications are focusing lenses, but also 1M, so one meta surface and 2 meta surface elements. So basically, that's where I wanted to chip in, because Bruno had a good talk, Simone had a good talk, and I think this fits in well in how we can reduce the complexity of these modules. I think it's time for that. 3D is here to stay. So now is the phase to make it more efficient. So anybody interested in that, I'm all ears.
Thank you so much.
Well, not a real question, but a response.
This is what I think Simon is looking for, and it's really good to know. Let me see if we have if we don't have another question, and maybe it would be very nice now to hear from PROPHESEE, from Simon. Simon, we would like to hear some of the from the application side and what challenges you can bring to us from PROPHESEE.
Hello, can you hear me?
Yes, we can.
Good. Let me share.
For those of you who don't know PROPHESEE, prepare to see something really spectacular. I think many of you already know, so you know what these guys do. For those of you who don't, be prepared. Sorry to raise the expectations very high, but they're already very, very high for me.
Thank you, Jose. And it's a very pleasure to be here again after a while. Can you see my screen?
Yes.
Crystal clear.
Good. Thank you. So for those who don't know the company, PROPHESEE is a company which is active in the world of neuromorphic vision system. We developed a breakthrough event-based vision approach to machine vision. And this new category of vision system allow for significant reduction in power, latency, and data processing. What we do develop sensors and algorithm. We call them metavision sensor and algorithm that mimic basically how the human eye and the brain work. To dramatically improve the efficiency in areas of different applications, which includes automotive, IoT, surveillance, AR, VR, and 3D is part of this, let's say, application. It can be used in different areas, right? The company is it's a startup or a started up, and we are based in Paris, so the headquarters is Paris, but we have local offices in Grenoble, in Tokyo, in Shanghai, and also in the Silicon Valley. Now, when it comes to, let's say, neuromorphic vision, I used two words, right? Neuromorphic and event-based vision. Those words are kind of synonym in this context. And the reason for that is basically that every pixel here in this kind of technology is independent from each other. And they embed some intelligence, so they react spontaneously upon changes in light intensity that happens in the scene. When this change happens, you have this event. So an event is emitted by the sensor. What is an event? So it's basically a signal which contains the X and the Y of the pixel that has seen a change, and the polarity of the change, positive or negative, so light intensity increase or decrease, and the timestamp at which the event occur. Now, these sensors are completely different from what you have seen so far. They are not, there is no more frame concept. Basically the emission is spontaneous and we don't have a frame rate, right? In the picture here, you see in the inset, basically, oops, sorry. A schematic of how the pixel works. So you have the pixel, you have a comparator, and then when you have a certain light intensity, you have these spikes. And the output of the picture is the one on the right, where basically the edges are very clear because they trigger this kind of change, while everything else it's gray, so there is no change, so no interest, no information, just useless data, so we don't capture it. There are reasons to do that, right? And the main reason, like I said before, is that the sensor is very fast. The time resolution is 1 microsecond. It's also high dynamic range. We don't use multiple exposure. Actually, there is no more concept like exposure time, and we can guarantee up to 124 dB. The low light cutoff is also very low. We're talking about 40 millilux. And we can generate from 10 to 1000x less data depending on the scene that you're observing. You can use this sensor and let's say the algorithm that we have developed with it for different applications. Today we are talking about 3D. So the sensor is one part, the projector is another part. So when you couple the MetaVision sensor with a projector, typically PCCL, but can be other projector, we enter in a new world of 3D structured light. So it is a structured light system, but we exploit the benefit of this kind of technology. So the fact that it's naturally capable of capturing movement like human eye, so it's very, very high speed. So what we can provide is a very high speed depth sensing. We basically low data rate, high robustness to the ground, and state-of-the-art accuracy. Where you can use this kind of new novel structured light system, we identified here a few of them. Today, it's well known that this smartphone you have like of front-facing, you do unlocking and payments with that. This is a given application. Way to move forward, we see different kind of applications that are not enabled today, and the reason for that is the sensors that exist are too slow. And this gives a lot of artifacts when it comes with motion. And where you need motion in this kind of application, for example, if you do virtual chat room. So this is an example of a virtual meeting, but it's not, let's say, as if we were in the same room. There are ways to let's say, go in that direction, but this needs different technology. And another thing, it's immersive AR, VR. There are a lot of headsets out there, but not a lot of volume, and the reason is that we haven't reached yet the performance we need. So when we do event-based structured light, we think we can, let's say, close this gap that is still missing for this application that needs, let's say, fast acquisition with good accuracy. Here you see 3 examples of our reconstruction, one for the face and let's say one for a game, which is very nice. I cannot show this video in this kind of presentation, but believe me, the game is very nice. You have balls that move here and there, and we're able to capture them, although we have a POC and not, let's say, a commercial product. And basically, the value proposition we are offering is, like I said, high speed with good accuracy, low power, and high robustness to background change. And basically, that's it. I hope to have questions and to have raised interest, because we need to, let's say, push this new technology and enlarge the community in event-based.
Thank you very much. For those of you who were not aware of PROPHESEE, I think they are already very famous. I hope you have been impressed by this event-driven image sensor. Simon, before I start with the round of questions, the question goes to you. The EPIC question. What can you do for the rest of the people in the EPIC membership, and what can they do with you?
What can we do? We can provide this kind of technology, which is, let's say, very new. So there are, for the moment, not a lot of partners out there with commercial products. You may heard that this year at the ISCC, we presented the latest version of our sensor with Sony. So not with a single partner, with a rather big one. And we can also provide our expertise in event treatment, because it's a new format of data, and the algorithm that we develop during this year of, let's say, research and prototypization. What we need specifically for 3D, we need light sources. We are not expert of projectors or making modules. We do design and we do design algorithms, but everything else we need partner for that.
I have a lot of experts on light sources. You're using VCSELs, right? What would be the ideal VCSEL that you have in mind? That would be the Santa Claus Christmas list in VCSELs.
Yeah. So indeed, thank you, Jose. I didn't give a lot of insights of the technical, let's say, breakthrough. I can't, because for that we need an NDA, so please come back to me. But basically the concept is that we need something which is not static, right? We are very good in capturing things that change over time. So we need a light source or a projector that is capable of emitting pattern that change over time. I know this is not very common in the industry. We can start with, let's say, static or semi-static projector to start the exploration, but the dream I would like to have is really an addressable VCSEL array.
I think that's good enough, because I already know what's behind addressable VCSEL array. If you have technology to make a very compact VCSEL array that could address every VCSEL independently, talk to Simon, maybe sign an NDA, because there is clear room for cooperation. You are a future gazelle of this technology, so thank you very much for being with us. We have a round of questions. The first one is, Simon, this one is the $1 million question. I go to SUS Micro Optics in Neuchâtel. Wilfred, what's on your mind?
Hi, very impressive indeed, an event-driven sensor. I just wondered, how do you discriminate between events? Is that your algorithm? Is this your AI? Is that application determined? And what if there are too many events? So is there a threshold or something? This is very impressive technology, I must say, but I wonder how it works, of course. Huh?
Okay, so for the, can you specify more? What do you mean when you say, how do you discriminate events?
Well, you said it's an event-driven sensor. So that means when there's something happening, something changes on your image.
Yeah.
Something is triggered on in your algorithm, on your detector schematics. So
yeah.
how do you discriminate then when there's too many things happening, too many things are changing?
Okay, so
let's say if it's a LIDAR system and you go 200 miles an hour, I mean, there's constantly changes. So how do you know what change is important and which one isn't?
So indeed, we had in the past videos with automotive applications. So the camera is mounted on a dashboard of a car. So everything in that case is moving, and indeed we are generating a lot of events. So how do you discriminate them? Is basically we were running machine learning application, and when you do that, you train the network to be compliant with this new type of event. So then automatically you do understand what is a car, what is a pedestrian, or what is background. In other cases, the background is not there, so it's easier. You just see things that are changing, but again, you need to retrain your networks. You cannot use something that is standard. To your second question, so when you have too many events, indeed this can be, let's say, a problem, especially when you upscale the resolution of the sensor. Today we are at HD. We've roadmap to increase the resolutions. This is basically part of the evolution of the technology, right? Like for frame-based, we first started with CCD and then CMOS, and then we learned a lot how to treat data in the ISP. In PROPHESEE, we are doing the same, right? We are learning how to treat the events in what we call ESP, or event signal processing, and in that we can reduce, compress, or let's say clean the flow of data that then goes to the processing part.
The first time I had the chance to visit in PROPHESEE in Paris when I could travel. I cannot travel anymore, and it's crazy. When I could travel, I went there, they showed me the demonstrators, and I was very fascinated, because when I asked them, what do you want to do in the future? They said, without hesitating, give vision to the blind. And that was very fascinating. I said, what do you want to do today? And most of the applications that you had in mind went in the industry automation, in the robotics industry. If you could highlight like the key application for event-related imaging, what would be?
In the industrial space, the key application, there is not one application, but what we have seen, there is a lot of interest in all the application where the performance is really important. So, for example, one application which is very hard or almost impossible to do with a frame-based camera is vibration. monitoring vibration or let's say kinematic movement with a sensor that is not mounted on a tool because you don't want to or it's too expensive to. That is very tough. With an event-based sensor, you can do it relatively straightforward, and you can measure the frequency and in some cases also the amplitude of the movements. These enable new possibility in predictive maintenance that are not so, let's say, easy with other sensors.
Since the last meeting that you spoke, Intel became member of EPIC. So I love when I say Intel is a member of EPIC. That means that we are doing something right. 631 members, one of them is Intel. Julia joined the previous meeting that we had on neuromorphic vision, which was fascinating. Julia, thank you very much for joining today from Intel. You just saw the presentation from PROPHESEE. They said the application fields that they are targeting. What are your views? What other applications you think we should go in the neuromorphic industry domain?
Let's see. So usually our kind of features that we try to leverage with neuromorphic vision and computing are high speed, so fast processing, low power, because both the camera and also the processors, they feature low power. So anything with a battery, anything always on, anything on a mobile platform, maybe like a drone or some mobile robot, that would be our domain. But also sensing in the infrastructure, especially if it's somewhere where we cannot get a cable there and we need to have battery powered device. And if we have some surveillance, some monitoring application where the sensor needs to be always on, and this could be in industrial setting, this could be in hospital setting, this could be just on the street. So there again, so these are kind of our domains. In terms of the sensor, an additional feature that it has is high dynamic range. So it works equally well at low light and high light. And that again opens, different applications, domains in automotive or, observing, monitoring. Yeah, so these are kind of our favorite
Thank you
topics.
very much, Julia. And it is great to have you in our network. For those of you who are looking for finding partnerships in the algorithms for vision systems, Julia is a top expert that we have in our network. It's great to have you with us. Intel is a member. Thank you so much for making this happening. I'm so happy to have this huge community. Why don't we go now to the automotive sector? We already saw the camera from PROPHESEE, and Julia said this could be interesting for an automotive. Let's see if that's true. Let's go to Scantinel, and the CEO of Scantinel, Andy Zott, is here with us to answer the epic question: how can we make Scantinel even greater? The floor and the attention of everyone goes to automotive LiDAR, goes to you.
Okay, thanks a lot. Very nice introduction. Okay, Scantinel Photonics has been founded about a year ago as a spin-out company from Carl Zeiss. So it's our mother company is quite well known. Scantinel itself, of course, not yet, but we are about to change that. So what are we doing? We are developing FMCW LiDAR. And FMCW LiDAR is widely accepted as a most promising next generation LiDAR technology for long range for automotive. So it's a key enabling technology for autonomous systems or autonomous driving, but also in the industrial space, there's a lot of applications for that. So you can imagine our system or product to look like a compact camera. So we have two fundamental unique technologies we are developing. One is a fully solid state scanning technology, which is a combination of photonic integrated chip, which you see indicated here behind this lens image in the light blue, and a combination of this chip and classical lens optics. And so with this approach, we can achieve fully solid state scanning without any moving elements. There's no MEMS, there's nothing moving. The second very important technology is the FMCW, so the coherent ranging engine. And here the key component, of course, is a very long coherence length tunable laser source, which is integrated also on the silicon photonics platform. So with that approach, we can achieve a very compact, and of course, due to this integration and manufacturability of CMOS electronics, also a low-cost solution in the long run. Here on the right side, you see a picture of our current multi-channel FMCW demonstrator. Of course, our current demonstrator that doesn't look like this. It's a little bit bigger, but still, it's a fully working system with 12 parallel FMCW channels, one solid-state scanning axis, and this demonstrator still has one mechanical axis. Here you can see a picture in about 150 meters range of a building, trees, and a barrier. So now, because this is a European consortium, I thought this might be an interesting picture here. If you look at the world map of FMCW LiDAR, there's a lot of activity in US and hundreds of $1 million investment flowing into that space. In Europe, there's, at least to our knowledge, only Sentinel. So that also means for us and in Europe, it's key cooperation, collaborations is a key element to compete and to win in this race. And therefore, I've also wanted to highlight here one collaboration. We are currently working with IMEC on the photonic integration, and jointly we are solving these key challenges of solid-state beam steering and scanning, and the integrated long coherence length tunable laser sources. And we are building on their very advanced silicon nitride platform. So this is a very valuable collaboration. Of course, now to answer Sana's question, I anticipated it. So, of course, if we have integrated chips, the photonic integrated chips, there are still a couple of discrete components remaining in the system, and we need to integrate them on the package level to make a compact multi-chip module. And we are looking for novel ideas from the community for these three areas I have highlighted here. One is micro isolators, either chip scale or micro optical component for isolation of a laser source. And semiconductor optical amplifiers with 2 to 4 watt output power and very high efficiency to reduce power consumption. And I forgot to mention here our wavelength is 1550 nanometer. Right? And finally, advanced assembly technologies for these micro-optical components related to photonic packaging, but also with micro-optical assembly technologies. Okay, that's about what I wanted to show you today.
Excellent. Thank you so much. And thank you for this great slide that will open a lot of collaborations today at this meeting. Let me first start with a question that we have. I have a few questions for you. The first one, I will go to Team Photonics.
Hello. Yes, thanks for taking my question. It was general for every LiDAR using PICs. How about the management of power on chip for laser damage issues, non-linearity of the material, etc.?
Yeah, of course, you need to have a very good temperature thermal control of the system. But I'm not sure what particular is your question targeting for.
Let's yeah.
Yeah, I was thinking, for instance, if you're using silicon photonics, I've heard that, and I know by experience that injecting a few watts of laser power on such platforms can be tricky. So I was wondering if you found a way to overcome it.
Oh, you mean the laser power in the waveguide?
Yep. Yes.
That is not a problem for silicon nitride. It's an SOI, that's a big problem, yes. But silicon nitride is solving that issue.
All right, thanks.
Thank you. We have another question from Simone, again, Jabil.
Yes, it's a twofold question. You mentioned a small form factor. I was curious to know what small form factor means and what level of maturity your current solution has in terms of automotive grade qualification.
The first question, it's 8 centimeters, 8 by 8 centimeters. That's the size we are targeting for. And to your second question, of course, FMCW in general is still early stage. We are not, we don't have automotive grade yet. So it's a demonstration system which can be used outside, which can be used in a demonstration car, but it's not automotive certified.
Okay. Would be interested to continue the talks afterwards.
Yeah, sure.
Yes, we will do all the introductions for you. And Andy, since you put micro optics as one of the challenge, I'm very happy to welcome today one of our newest members, 3D AG. If you're looking for a one-stop shop of designing and manufacturing of optic and nano optics, we have here Marek. Marek, how are you doing today?
Hey, thank you very much for introduction. We're doing very good. As you mentioned, 3D just became a member of EPIC. We are really proud to be a new member of EPIC. I've been already to a few conferences, few meetings before, and I'm really happy to have a chance to give a very short introduction to what 3D was doing in past and what 3D is doing now. I can also share my screen here. I see that. I think this is your slide. Thank you for the slide. So originally, 3D AG was funded for holographic originations of high security features. But as you know, these holograms can only be made in a small glass plate, like as every other origination. So we have a very good electroforming capabilities, and we use these electroforming capabilities also to produce nickel shims of nickel molds for production of the mass scale of this of the any kind of micro optics or freeform optics components. You can come to us in every stage, which we like to call us a one-stop shop, where you can come at the very beginning with the idea of the structure that you need. We can originate the structure. We don't have capabilities to originate micro optics here, but holographic structures we can originate in-house. So we can originate it in-house. We have also a lot of partners that can originate with us, work with them on a regular basis. Once we have the structure originated, as you see here, this will be a micro lens array. We can electroform a rigid mold for rigid nickel molds. This can be used for mass scale replication already directly from this stage. Or we can recombine it to a larger area. So we get a step and repeat, a self-developed custom high accuracy step and repeat recombination method. Where we can take your small sample and expand it to much larger area. So you would have a much larger active area for processing. You can also laser cut it and weld it if necessary to sleeves, maybe for roll-to-roll manufacturing, or this can be used for injection molding very often. So you can come to us in every stage. You can come at the very beginning where you have only the idea of the structure. You can come to us with the structure already on a wafer, many different base materials, and we are happy to help you to turn it into a nickel mold for mass production. Thank you.
Thank you so much, Marek, and welcome again to EPIC. And let me see now if I think I have another question from AZOnetwork, right?
Yes, coming back to Scantinel, actually, I just would like to mention that if you need any support of automation in terms of ramping up in medium or high volumes, we should maybe line up then.
Absolutely, yes. Of course, we know AZOnetwork.
And we have even another question from IBU. Hanno?
Yeah. Hi. Thanks for the nice talk. And coming from a different company, different approach, we are time of flight LIDAR users, and yeah, to my understanding, for FMCW, it's always challenging to do the scanning. Can you maybe expand a little bit on how you try to realize that solid state scanning within FMCW?
It's an interesting part. It's actually the hardest part of FMCW. So unfortunately, I cannot disclose it. But,
clever, Hanno.
I cannot disclose the secret of Andy, because the secret of Andy is the secret of Europe and is very well kept. But if you want to know a little bit of structuring light with silicon nitride, ask Lionics International. That's the hint I have for you, Hanno. Ask them, because they have some very, very good ideas on this. Sana, I have a question from the YouTube universe. Gregory Flynn from FiconTech also is asking about what sort of volumes is Scantinel expecting, and also how many process steps, and I guess a more or less finger on the air number, how many process steps are in the manufacturing process?
Okay, if it's a FiconTech, it's probably about the final assembly process, but probably that's something we can discuss in a one-to-one or offline.
But you are targeting, this is from me, forget about FiconTech now, I never forget about them, by the way, but it's from me. We are targeting now FMCW for automotive. You are bringing the silicon nitride platform of IMEC, which is a success story of the European ecosystem, to have silicon nitride, LIGENTEC, Lionics, and IMEC, to the automotive sector, where they have never been there before. I know that SAIS is very strong in automotive, and that's the mother company. Is there a roadmap to bring silicon nitride photonic iterative circuits for automotive with all the validation and testing required?
Probably there's no such thing as a roadmap like you know it from a semiconductor industry. I think that's not existing in automotive. It's something we have to develop and push and show that it's working in an automotive environment. That's our task to do now.
I love that task. So let me take it on board. I'm going to go to Lionics International because I think I have somebody from Lionics. Is that correct? Somebody from Lionics in the room?
Yes, I'm here.
Yes. Oh, Dawe, first time we meet. Dawe, how are you doing? Thank you very much for being with us today. Lionics is doing silicon, well, it's triplex, silicon nitride, silicon oxide layers. You are targeting many application fields, including automotive. Could you tell us a bit about the maturity of silicon nitride technology for automotive?
Silicon nitride.
Yeah, well, iterative photonics in the wavelength range that Scantinel is doing, which collides very much with Lionics one.
Yeah. So, well, we have been in silicon nitride since the start of Lionics, since 2001. So it's a very long-standing technology, which can be very robust. Indeed, the advantages of silicon nitrides are in these high powers, with respect of silicon, where you can deal with much higher powers in the waveguides, but also wavelengths other than 50-50. And in the end, it comes down to not only the silicon nitride chip, right? It comes down to the module, as Lionics also always states. So you need to deal with how to assemble this chip right from the start, and that's where Lionics International's vertically integrated approach supports its customer. I hope that
I saw your demonstrator structural lighting that you brought to the meeting last year when we could travel, and I'm very amazed of what you can do. So I hope that if there's some room for cooperation. Yes, of course.
Yeah.
I'm also on YouTube a lot. I don't know if you see me in YouTube.
Right.
One question back for Scantinel. You are looking for SOAs to 2 to 4 watts output power, of course, with high efficiency. Is there any demands when it comes to power consumption and when it comes to the size? Because I guess you want to integrate them in the whole FMCW module.
Yes, I think expectation from automotive industry is below 20 watt for the complete module.
Is that state of the art? Did you find already? Because I already saw, and you're doing some Googling, it doesn't look like something very achievable. Is there a state of the art there? Do you have perhaps some hints into the possibility of having this? Otherwise, I'll find it for you.
Yeah, please find it. No, we have our own estimations, and I think it very much one of the key elements is actually the amplifier efficiency. And if we think we can achieve that level, I mean, today's state of the art time of flight system, probably EBO can tell more about that, what kind of power consumptions they have. But if you look at data sheets, they are in that range, about 20 watts. But of course, it's time of flight system and shorter range.
it is of course a big the challenge of Scantinel is the assembly and packaging. I know that you have the right partner, so you have already worked a lot with the EPIC network, so thank you for being such an engaged member. If there are any other challenges, you can share them with MDA, of course. And Sana has her hand up.
Yes, I would like to introduce Tobias from ACM on a different thing. They do manufacturing, but I would like to hear from you your question, Tobias.
Yes, thank you. I was wondering, what is for you the more challenging assembly task for a PIC-based LiDAR system? Is it the fiber attach, the PIC integration, or is it the relative alignment of sender and receiver side to each other?
It's a relative alignment of components. We don't want to have fibers anymore in the final system. It should be left off completely. But of course, you have a multi-chip system, and you need to align the chips, one chip to the other, and that's the most challenging task.
Yeah. Okay. Yeah, I'd be happy to discuss with you.
Okay.
Potential.
Andy, as you mentioned IMEC, I would be really happy to hear also from IMEC about. Amin, tell us more about IMEC and the successful collaboration.
Thank you. If you, I have a chance to just share my screen. Yes. Okay. Thank you very much for this opportunity. I prepared one slide about our technology. Andy already mentioned, so it was good. But I saw some this question about this high power handling and also in the same time having integrated. So what we have, this is mature 200 and 300 millimeter platform, foundry platform. So most of the people know IMEC as an R&D center. But I wanted to show that also we are a high volume manufacturer. So we are just in the unique position of having this R&D center. We have a design house characterization, but in the same time also we are just producing these photonic chips in a high volume, about 1,000 wafer per year per customer. We have a capability and 3 flavors of these silicon nitride. LPCVD silicon nitride, high power, low loss, PCVD compatible with CMOS imager. You can see a couple of examples here. But what is unique about IMEC is the silicon nitride on SOA, on silicon photonic. So we know that silicon photonic is fantastic, has a fast modulator, fast phase shifters, and also the modulator. But we are mixing these 2 platforms. We have this unique silicon nitride on SOA. So this is the one techniques that I think helped Scantinel to realize the FMCW. So this is our example that we have demonstrated in-house. This is the LiDAR system we have built. And as you can see, we have this demonstrator. We could just cover 40 degree in the horizontal line and also 15 degree in the vertical line. Another example that we have, it is this structural light. We could also, with the same platform of silicon nitride on SOA, we could just generate this steerable structural light. It is not a fixed structural light, it is steerable. So we are not only platform provider, we are also on the laser integration, also top illuminative germanium PD. That is also one of the key components for the LiDAR for LiDAR application. So we have this all one shop for the PIC component that customer can just reach. So they could just approach us, and we have just full shop for all the component for LiDAR application.
Thank you so much. Thank you so much for this brief and efficient introduction.
I wanted to be fast.
This is excellent. That's excellent. Let me see before we move on to another question or to the next speaker. Let me see if we have another question in the room. Okay.
Well, I don't have a question, but still there is a challenge here because we are talking a lot about the assembly. And the assembly is on one hand the alignment, which they can do very well. On the other is to use the right adhesive, and especially for the automotive industry, this is not obvious. So Andy from Scantinel, I'm still very amazed, and I want you to succeed. When it comes to the process for the automotive industry, is there challenges with the right adhesives? Is that something that the industry can help you?
Yes, that's,
Yes,
that's
I
idea.
wanted that because I wanted you to hear from my friends from DELO. Tim, how are you doing? If DELO cannot help you, then nobody can. Tim, what do you do in the field of optical adhesives, and how can we help, all of us, how can we help Scantinel? We need FMCW in Europe.
Yeah, thank you very much, Jose, for joining in this nice meeting and for your organization. We from DELO Industrial Adhesive are always ready to help with our solutions, especially when it comes to small fixation durations, high UPH, and so on, and also very precise alignment. So this is the main benefit of our adhesive capabilities, and therefore mostly the light fixation or light curing step is very essentially for our products, but also dual curing capabilities, for example. And if this is of specific interest, to have something like polymers which are curable in various ways to help to your process and also for your specific optical alignments, then we are some kind or very interested in collaboration with you and also to maybe help you with some engineering on your further and future products.
Great.
Thank you so much. There is always room for collaboration here, and maybe we can put you later in a one-to-one meeting. My next question is from Sand Microsystems. Why don't you ask directly the question, Farzad?
Okay, hello. I just write it to you first. Yeah, my question is, what is actually the targeted resolution of your FMCW LiDAR, and how do you deal with the laser linearity issue that is tightly connected to that?
Resolution, axial resolution is about 10 centimeters is enough for automotive application. So let's say in the centimeter range. And linearity, we have a special technology. We are using carrier modulation, so not sideband modulation, and we have a specific linearization technology.
Okay, thank you.
Thank you so much. Then in this case, allow me to introduce our next speaker, who spoke already a few times. Hanno, the word is back to you.
Thanks. Thanks for the introduction. Yeah, let me quickly share my screen. All right. So yeah, thanks a lot for giving me the opportunity to talk here again. My name is Hanno Holzhüter. I'm working for a company called IBO Automotive Systems, and I'm very happy to have the first talk, the previous talk here, talking about FMCW LiDAR. So this is now the counterpart to that, our time of flight LiDAR sensor, which you can see here, which is the module that we've developed over the past few years. So the topic is going to be automotive LiDAR series in mass production or in series production. And I basically want to walk you through what is necessary or what you need to have a LiDAR sensor in automotive mass production. So first of all, you of course need a company. Let me very quickly introduce you to IBO. We've been founded in 1998, so been around for quite some time now. We specialized in the field of automotive LiDAR sensors, and here we do the whole processing chain. So we are not only developing the hardware, so the sensor themselves, but we're also doing the point cloud processing, which you can see here. So we're trying to detect the object and track them. And we also realize the driving functionalities, as you've actually seen in the introduction video already. So we really have the whole chain from developing the hardware down to realizing the driving functionalities in our cars. We have over 420 employees by now. Our headquarters are located in Hamburg, but we also have offices in Eindhoven and Detroit. And when it comes to mass production or series production, it's always helpful to have a big automotive tier one, which in our case is ZF. We have a partnership with ZF since 2016. And yeah, this is something that's of course very important when it comes to mass production. What is equally important is a customer, and I'm happy to say here or to emphasize again that roughly 3 months ago we were able to sign a contract with Great Wall Motor, a very big OEM from China, and this is actually, they awarded us with a contract which is actually the largest automotive LiDAR series contract that has ever been signed. So this is of course something we are very proud of. Here in the picture you can see our CEO shaking hands during the signature process. And what I want to mention here is we have this sensor that you can see here in the bottom, which is called our generic sensor, is available now. So if you want to try it out, mount it onto your car or maybe onto a robot, some industrial applications, feel free to contact us. I'm happy to forward you to sales. So this is really now ready to be shipped, and yeah, you can try it out if you like to. Okay, let me quickly also give you a few details about the sensor itself. When it comes to mass production in the automotive market, as we've heard before already, cost efficiency is always very, very important, and also form factor. So here you can see our LiDAR module easily fits on the credit card, so it's very, very small and also light for that reason. And it's also important to have application-specific integrated circuits. So we designed 3 ASICs, and this is actually something I'm also happy to say here because I think there's some overlap with PROPHESEE. We have on the emitter side, we have a VCSEL array, so we have addressable VCSELs here, over 10K pixels that we use for emitting of our short light pulses. We have 2 drivers on each side that drive these VCSEL arrays, and on the receiving side we have a SPAD array, single photon avalanche diodes, again over 10K pixels. So what we're doing is we have 2 arrays that are being electronically scanned, so the corresponding pixel on each individual arrays on the receiver and the emitting array are always active. So in this way, we can address both of these chips and scan electronically, and therefore also solid state, which again is very important when it comes to automotive mass production and also durability. What is also important is when it comes to the customer, of course, you don't want to only provide one sensor, but you want to be some kind of flexible and serve the different requirements from different customers. We realized that by having multiple different optical modules, so you can see here we can exchange our optics module that is mounted on this base LiDAR module or base plate here. And depending on the optics, we can realize different ranges. For example, you can have high resolution, long range module, or you can choose a wide angle field of view with, for example, 120 degrees. So if you're more interested in having a wide field of view, but range is not that important, we can go for this with different optical modules that we have designed. Okay, there are different ways how you can integrate these things. There's the generic module, as I said in the beginning, which you can see at top right, but we also have what we call a corner module. Here we have a long range module and a wider field of view module integrated in one corner. We mount it in one of our cars, and just to give you an impression of what you can do with it, I brought a small video here. And there's one thing that I want to mention about the LiDAR here as well, is that it's a digital LiDAR. So what we're doing is we do digital signal process on the time of flight signal that we're receiving. And for that, we can not only extract the distance, so what you know from the point cloud, the distance information, but you can also extract additional information. For example, how many photons do come back. So the amount of photons that come back is what we call intensity, but we can also extract the amount of background light. And what you see here on this image is now the point cloud overlaid with the intensity image. So in grayscale, you will see how much energy we are receiving back at our detector. And let me quickly play it here. This is 25 Hertz in case it stutters. But what is amazing to see here is how easy one can detect different cars and different objects because it's overlaid with this grayscale image. And I want to underline here that this is only recorded with our LiDAR sensors. So there's no camera involved. It's purely LiDAR sensors, the digital LiDAR that we developed. And it's easy to imagine how valuable such data sets can be when it comes to autonomous driving or higher level autonomous driving. Okay, with this being said, quick summary. So I showed you what we can do, what we're doing. We're developing the hardware, doing the processing, and also the driving functionalities. We have been awarded with a LiDAR series contract very recently, which is of course something we're very proud of, and the right step, big step in the right direction. And what we can do with this, with our sensing device, you have seen in the last video, where we have an enhanced point cloud due to the fact that it's a digital time-of-flight LiDAR. With this being said, thanks a lot for your attention and happy to answer your questions.
Hanno, I already congratulated many of your colleagues in private. Today I had the chance to do it in public. Congratulations. This is such a huge step for what we are achieving here. And I also know that you and some of your colleagues have been very active on engaging with many EPIC members. Part of that accomplishment is also part of the technology on with 2 technologies of EPIC members. Very happy to that we introduce companies and afterwards they work together. Yeah. And until there I can read. I don't know if you can read a bit more. Who is the supplier of the automation machine that is assembling the LiDAR? Can you say the name?
Yeah, I think I can. I mean, he spoke already, so it's ACMtec. Tobias has already spoken. Yeah, so we did our assembly line, or the first assembly line that we used for our LiDAR sensor has been provided by them. So it's a good collaboration that we had in the past few years, I would say even. So yeah, this was definitely a good step into the right direction, and has actually led to
from the assembly of components to serving car makers, already a tier 1 supplier.
Yeah.
We have a lot of questions for you. Let's start. We go first to Finland. It's gonna look a bit like Eurovision now. We go first to Finland. We go to Jari from Modulite. Jari, what's on your mind?
Yes, thank you for taking my question here. Can you tell a little bit more about the VCSEL that you are using, in a way, the wavelength and so on?
Yeah,
you mentioned only the matrix, but in a way.
Yeah, sure. Yeah, so we are using 885 as a wavelength. So it's a silicon-based sensor on the detecting side. We have over, so it's an array. We have over 10K pixels. It has a high slope efficiency, which is actually something we are always looking to improve, because power consumption is a big issue, and you of course want to emit as much light as possible. Yeah, it is.
Yeah,
that's
we definitely would be. Maybe we could actually talk a little bit later after the session, or later in
Sure.
during contact. Yes.
Sure.
We
Right.
go from Finland, we go to Dallas. We go to Texas Instruments. Benjuan Fan from Dallas, USA. What's on your mind?
Hello. So my question is, how do you deal with the interference signal from the neighbor cars in the LiDAR system?
Yeah, so what we are using as a scanning technique is called time-correlated single photon counting. So we are emitting multiple pulses, and we have some kind of random jitter in between these pulses. So we can somehow code, or in a way code our pulses that we are emitting. And this is one way how we deal with interference from other sensors, but also we have a scanning device. So we only look into one specific portion of our field of view at the time, and the likelihood that we have an overlap there is with another sensor is quite low. And even if we have one, it would only contaminate one pixel and not the whole field of view. So this is the benefit of having a scanning system, and also a pseudo-coded time-correlated single photon counting measurement technique.
The third question is coming from me. So you integrated VCSEL, drivers, and SPADs, and that was huge, because one of the first one who really do it all the way to serve the automotive industry. You are using 10,240 pixels for the SPADs. Is there, if we had this conversation in 2 years, would you tell me something differently?
What do you mean? The number of SPADs that we have integrated on the chip?
Are you going towards increasing number of SPADs?
Yeah, sure. You mean in the future? Yeah, for sure. The automotive industry is always asking for more. I mean, this is a good starting point now, but they are not satisfied, and there will always be some gaps. So the resolution has to be increased. And for our next version of the LiDAR, we have at least 4 times the resolution, I think. Yeah, so there's definitely more pixels coming.
One of the important part when I see, I'm going to show again the slide because I think it's really beautiful. When I see your slide about the different integration process that you follow, one of them is the accurate integration of optics. For the future, I do believe the future of all these optical instruments, they're going to go into the micro-optic array solutions. Have you been, I know you have because you came to many meetings on that.
Yeah.
Have you been looking at this, and what kind of ideas do you have for the micro-optics community that is with us today?
Yeah, sure. So micro-optics, I mean, especially micro lenses directly attached on these arrays are always very interesting. It's a big challenge to reduce the photons that you're losing in between these pixels. And there are many different ideas how we can deal with this, applying micro-optics to our chips. So there's definitely huge potential, I would say.
Do we have somebody from Nanoscribe in the room? Nanoscribe is here. Oh, yes.
Yes, we do. Yes, we do.
Yeah, do you know what he's talking about? Integration of micro optics and stuff. Can you help?
We can help indeed. So if you allow me to share my screen for a moment.
How can I not allow you to share your screen?
Thank you very much for that. So we at Nanoscribe, we are producing manufacturing machines that can be used and are already used in the industry for micro-optical prototypes and masters. And this includes, of course, micro lens arrays, as Hanno just mentioned, but also diffractive optical elements, as they were mentioned several times before, for example, in the context of structured light. So this is based on two-photon polymerization, which is now starting to be a well-established technology, I think, for producing structures like that. But we put a little twist on that too by using something called two-photon grayscale lithography, which I would be happy to explain afterwards to anybody who's interested in this. And so basically with these machines that we produce and provide, you can create high quality micro-optical structures, lens arrays, diffractive elements, or any kind of combination of that. So high level DOEs or hybrid structures are possible as well.
So you saw the presentation from Hanno. By the way, Nanoscribe that has this technology which is fantastic to photon polymerization, and we have other companies in Europe that can also supply this kind of technology. I would say Multiphoton, Vanguard, many. Today we have Nanoscribe. Nanoscribe, you see the challenge of EVGroup, which is to reduce the size of the optics into something very, very small. A challenge for the future, not for the present. How do you see the automotive market taking these advanced micro optics?
We don't have direct contact to automotive since we are just supplying to the suppliers of the suppliers in the end. What I can say is that with our technology, it is possible to integrate optics. First of all, you can put the lenses very densely together. You're not reduced to having a certain fraction of the area because of your finite tool size. You can combine several optical functionalities into one set of optics that is printed directly. You can stack several lenses on top of each other with this technology. So there is a high degree of integration and miniaturization possible with this technology.
I let you discuss, because of course with EVGroup you get everything in one shot, because they go from the manufacturing all the way to serving the car manufacturers. But Hanno, I'm not going to let you go so easily. There's one more question which I actually love. I go to Dallas because Benjamin Fan from Texas Instruments has the $1 million question. Ask us about the 10K pixel array. Benjamin Fan, what's on your mind?
Yeah, another question. For this more than 10,000 pixel arrays, so what's the die size and how to package them and how do you manage the heating?
Yeah.
And is there any particular reason to select 885 nanometer wavelengths?
Okay, so I'll try to go through these questions one by one. So first of all, die size. Yeah, it's a fairly big die. I don't think I'm not sure whether I can give you the sizes, but it's a few millimeters. So it's definitely a bigger chip. Managing the heat. The thing is, we don't activate all VCSELs at once. So we are scanning in sequence. So this is what we call electronic scanning. And actually, the duty cycle of each pixel is very, very low. So what we are emitting is we are emitting very short light pulses on the order of nanoseconds. So the time that these VCSELs are on is quite low in comparison to the time that they are off. So the duty cycle is very low. That, of course, helps when it comes to heat dissipation. And for your last question was, I think regarding the wavelength, well, you always want to, we have silicon detectors, and silicon has a very hard drop-off when it comes to 1.1 micron. So in sensitivity, so what you want to do is you want to be as close as possible to the visible range of the human eye, but still be outside the visible range so that not everybody sees your LiDAR sensor flashing. And for us, we simply went for 885. I'm not sure whether there's a particular reason, but we definitely want to stay in the silicon range and be as sensitive as possible with our SPET detectors.
Hanno is a star of the EPIC network. So if you have challenges, opportunities for collaboration, ideas, talk to him. Hanno, thank you so much for what you're doing. Thank you very, very much as a success story of EPIC network. Thank you, Hanno.
Thank you too for having me. It's nice again.
For all the LiDAR companies, not only EVGroup now, but for Scantinel and all the others, Vimagine, Julia from Intel has a challenge because Julia wrote something very interesting in the chat. Julia from Intel, what's on your mind?
All right, thanks. Yeah, so my question comes from user of the sensor, and the user would take the data and then try to actually solve the problem, detect those cars or other objects. So I wonder how many people have tried that already, in particular with that last sensor that was presented that also has some kind of intensity values attached. And independent of the answer, whether someone has tried it or not, what do you think would be the challenges versus advantages compared to image-based classification of things in the world?
Maybe I can say some words to it. So the intensity image is something that is, as you said, very valuable, and also for image recognition, car recognition, we have trained several networks, neural networks on these data, because it's basically a grayscale image that you can use for image recognition, and this is something that works very well. The downside is that the resolution is not as high as if you would use, for example, a 4K camera or some other camera. So the resolution is not as high as for a camera, but training your networks based on this intensity image, or we have other types of images, works very well, and we have done that in the past in several theses. So this works very well.
Thank you.
Julia, are you satisfied with the answer? I think you look, but I would like to have a very long debate now. If PROPHESEE, what are the views, and Scantinel, what are the views? We're going to do that round offline because we really want to finish at 5, and we're right on time today. Sana, could you introduce the final speaker who is going to send us off the way we deserve?
Yes, our final speaker woke up really early today to join this meeting from the US. How are you doing? How are you doing, Hod? We can hear you now.
Yeah, I'm still awake.
Yeah.
What time is it over there? Here is 4:45 in the afternoon.
It is just 1 second. It is 7:45 a.m.
Time for the first coffee of the day.
Yes, just 1 second. I'm trying to get my presentation up. Okay, hopefully you can see it now.
It's up. I was inviting him for the robot meeting, and he's like, "No, I have to be in this one first." So yeah, go ahead.
Okay, great. So thanks for having me, and it's nice to meet the team here. So I represent Sense Photonics. We are a San Francisco-based company, but we do have European presence. We have an advanced development center in Edinburgh, in Scotland. So what we do is we are a little bit like IBEO, a vertically integrated LIDAR company. And we think that we provide the world's most powerful 3D perception system. And really, this system is kind of like a paradigm shift in the way that LiDAR is done. We provide very rich data sets that include the 3D point cloud confidence data, reflectance of targets, and fusion with RGB cameras. So we call it RGBD. Our system is all based on semiconductor technologies. It is solid state and has no scanning whatsoever. So we don't do any mechanical scanning. We also don't do any electrical scanning. And really our architecture is simple, manufacturable, and it is much more like a flash DSLR camera than it is a traditional LiDAR system, in that the resolution is dictated by the number of pixels in our focal plane array, rather than by the number of scan points or the number of lasers on our emitter head. So we basically optimize all of the technologies that go into a LiDAR system. So long-range LiDAR as well as short-range LiDAR is a really difficult problem to solve. And our global shutter flash LiDAR camera has our proprietary technology both on the VCSEL side and on SPAD. On the VCSEL device, we have a proprietary technology that's called microtransfer printing, which instead of using VCSELs on dyes, allow us to print VCSELs, and we have tens of thousands of VCSELs on a very low-cost flexible array. And we integrate this flexible array in an integrated emitter module together with diffusers, so there is no active alignment that is required on our systems, and it is class 1 eye safe. We also have one of the most advanced SPAD design teams in the world. We optimize the whole imager chip from a 940 nanometer optimized high count rate SPAD diode. We design our own SPAD pixel, and we have designed our own imager chip. This is the largest SPAD array commercially available in the world, with well over 100,000 pixels, offering a really unprecedented resolution. And really the key is that we integrate all of the components together with standard semiconductor technology to offer a low-cost manufacturable and high-resolution system. So these are really the two key technologies. They are very different than what is available today. This is our illuminator. What you see here is our earlier generation emitter, which you can buy today as part of our mid-range LiDAR system that we mainly sell for industrial applications. It has well over 10,000 VCSELs that are custom printed on a heat-conducting flexible substrate. This is our SPAD array. It is a backside illuminated CMOS SPAD array, again, leading edge in terms of semiconductor technologies, with well over 100,000 pixels for 100 kilolux operation that we have demonstrated in hundreds of meters range with the low reflectivity target. So we think that the Sense Flash technology affords a really nice value. It is 100% solid state, high resolution. So we are at 0.1 degree by 0.1 degree resolution. We have a true global shutter. So as you know, in LiDAR, you actually move. So motion artifacts are a major concern, not with our architecture, because we illuminate the whole field of view at once, and it's a wide field of view, and we acquire the whole field of view at once. Because we have a true global shutter, we can do RGB fusion without any timestamp correction for motion blurs, and a very low BOM cost. And this is not just about the BOM, but also very easy assembly and alignment, and we are not susceptible to vibration and shock. Let me show you some videos of our system. This is our mid-range system. On the left, you can see a well-known 40-channel rotating scanning system, and this is the output from our mid-range LiDAR system. You can see the much higher resolution, and this is the actual 3D point cloud. So we're not overlaying it on any CMOS image sensor output. And this is due to the 100,000 pixel resolution of our first generation system, which again, we're going to go much higher in the next gen that I just showed you the detector for. So we also perform the image processing. So we really own the whole stack. And here you can see a person monitoring, which in the COVID case is becoming a very interesting market space. Since we offer very high resolution on our 3D point cloud, our algorithms are able to track individual people without actually identifying them. So in terms of privacy concerns, this is a major plus from what we hear from our customers. And the last slide, in terms of the EPIC slide, so even though I'm new here, so really the areas that we're interested in is working on beam shaping optics. We have a very unique emitter architecture in that we have a diffuse emitter. We actually curve that emitter. We can curve it up to 180 degrees on our flexible substrate. So the beam shaping optics is becoming interesting. We are interested in manufacturable, low cost and reliable solutions. And of course, we're interested in commercial collaborations for LiDAR deployment. So thanks very much.
Thank you so much, and thank you for getting quickly on the train of how EPIC works. And you got to that we are always looking for collaborations for development. So let me see if we have first somebody in the room to answer your request. Do we have any questions? All right, so tell me, you are looking for beam shapers for what? Can you give more specifics?
Yeah, so we basically have so as I mentioned, diffuse flexible emitters. And one of the architecture traits for our system is that we can, because we're a flash system, we can define different fields of emission just by replacing the diffusers. So whether this is a wide field of view or a narrow field of view, we can actually also tune the field of view as a function of our range. So you can have different ranges, different fields of view for different ranges in real time when the system is scanning. And so there are, micro-optical, diffractive optical elements that we are interested in integrating into our system.
Thank you so much. Let me see if I have any questions in the room.
Yeah, so I see that there is a question from ST about wavelength. So we're working at 940 nanometers. 940 nanometers offers a nice trade-off. The biggest enemy, I would call, to SPAD operation is actually not signal, it's background. And so at 940, there is a solar minimum. We also utilize optimized SPADs with 940 nanometer increased sensitivity. So, yeah.
Thank you so much. And there will be room for collaboration. I'm sure we will be able to introduce you to more of EPIC members and to the EPIC network. Let me see from our guest today, from SUS Micro Optics, how do you find the meeting so far? And if you have something to comment on what Sense Photonics are doing. Wolfgang? You need to unmute. It's okay. Okay, otherwise I go to EVG. Martin, you can ask your question directly.
Hello, I was wondering, when I understand your question correctly, you want to correct pixel-wise the beam shaping, and it sounds like a task for wafer level optics, maybe? Did you consider that?
So it's a good topic to discuss with EVG, definitely. I'll be interested to continue the discussion, definitely, yeah. Wafer level optics is something we're interested in.
Oh, perfect. Yeah, let's discuss later.
Yeah.
All right, then we can have this request to Elena to put you later for a quick discussion, and we can introduce you, of course. Let me see if somebody else have a question. Otherwise, I would really like to hear from CDA. Pia, how do you find the meeting so far?
Let me unmute. Excellent. Perhaps then I'll ask also a question. Is there any material requirements on the micro optics?
Well, certainly we need to be automotive qualified, and we need to, the automotive environment is a harsh environment. So there are certainly reliability and humidity and temperature requirements that we need to adhere to, yeah.
Okay, but polymers would be an option.
Yes. Yes.
Okay, and then potentially we could also discuss then later on this topic.
Sure, yep.
Excellent. What about coating? Because in that case, I would like to give a word to our friends at Optics Balzers.
Yes, thank you very much, Sana. It's interesting to see in the meeting so many different 3D imaging technologies, and also on the LIDAR side, I think we have seen all kind of different competing technologies. And if I'm allowed, I would also quickly share a single slide. Sure. Just a second.
Yeah, we can see you sharing. Excellent.
Excellent. Just wanted to give a short update. I think in a very similar group about half a year, there was also a question on optics pulsars. Back then, we've just been acquired by the Materion group, and I think now I can give a bit of an update. So Materion covers 3 different divisions, and optics pulsars is now a member of the Precision Optics group. So our name Optics Pulsars will still remain in this large global cooperation. And I'm also looking forward to some very interesting topics. So in some of our other divisions in advanced materials, there are also new now microelectronic packaging materials, and I think they're very interesting product combinations in the future. And then if we look at the bottom now, just in the Precision Optics division, we now combine more than 150 years thin film coating expertise, and all over the world we have more than 160 chambers, and I'm sure in some of these chambers we are able, for all the 3D sensing solution that we've seen out here in the webinar, and also see in the market that we can serve all these different industries with coating solutions for 3D imaging, and that starts from industrial LIDAR or industrial 3D imaging solutions. We also have solutions for automotive LIDAR, gesture recognition, and what also has been presented earlier on the call, solution for facial recognition, gesture recognition in consumer devices. With that, I would like to close and give back the presentation to you. Thank you for that.
Thank you very much. Thank you, everyone who has contributed to this fantastic meeting. I love finishing on time. We went through 2 fantastic hours of your life, and I always take my learning points. My learning points today was that there are, for me, 4 very, very interesting collaboration opportunities here. On the neuromorphic vision, pixels array packaging. Talk to PROPHESEE, they have a challenge there. On the FMCW LiDAR, the SOA that they are demanding is specified in the slides. Have a look at that. The time of flight LiDAR, micro optics, VCSELs and SPADs, integration process automotive qualified, and Sense Photonics being shaping optics. Also, we had some great breakthroughs. I love from the FMCW LiDAR solution what they told us about the collaboration with IMEC using silicon nitride for this very difficult scanning, as Intel pointed, of FMCW. I also love the microtransfer printing technology used by Sense Photonics. Microtransfer printing is a technology that is going to do a huge push now for the micro LED technology, and what they are doing now, bringing it to the LiDAR industry, is huge. PROPHESEE keeps impressing us. This event-based imaging actually generating less, or up to 1,000 times less data, and the Broadcom 1-12 silicon photomultiplier detector, price, size, and heat complacent to the LiDAR industry is also a huge breakthrough for me. I just love you guys. I just love you people. It's such a fantastic set of meetings that we are happening. I live next to the beach, so you look through this window, you see the beach on North Bank. I come from the south of Spain, so the Netherlands, 2 leaves, wind is great, beach is just okay. But what we are doing here, bringing all the photonics industry and find ways to collaborate, really makes me happy. So if you want to get in touch with any of the participants today, all you have to do, send me an email. I love answering email, jose.pozo@epiclassazov.com, and I will be more than happy of making the introductions. It is all about introducing companies. It is all about creating business on behalf of the huge community, on behalf of a fantastic team of experts in the medical, in integrated photonics, the laser technology, in the optics. We just want you to integrate with the fantastic EPIC network of 631 members. Now, all of you who are watching in YouTube, time to disconnect and have some family time.